Today we are going to be looking at two pieces of equipment you'll find on your A-level physics course called micrometers and Vernier calipers, or something that uses a Vernier scale. Now we'll use them in required practicals, usually to measure small things, and they're basically an improvement on a ruler, and I'll show you how. So let's say you're trying to measure the diameter of the end of this pen. Now with a ruler, it is kind of tricky to do, so you can measure it kind of flat. I'm going to hold it up to the screen so you can see it a bit clearer. I'm going to say it is about 4 millimeters here. With 4 millimeters, the resolution of a ruler becomes really important, because the resolution, which if you don't know, that means the smallest thing an instrument can measure, or the smallest interval that a instrument can measure. The resolution of a ruler is 1 millimeter. Now, I hope you can see the problem here. If the resolution is 1 millimeter and the diameter is 4 millimeters, well actually that means there's about 25%, or 1 in 4, a level of uncertainty here, because it could go up as high as 4.5, could go down as low as 3.5, which is not good for one single measurement in a practical. So let's have a look at something that might be a little bit better, and we're going to start off with the Vernier scales. I'm going to show you what a Vernier caliper looks like. So this is what's known as a Vernier caliper, and it has a Vernier scale on it. You can find Vernier scales in other places, like when doing the Young Modulus practical, but here we've got them on a Vernier caliper. Now the idea is you can adjust the jaws to fit around the object you are trying to measure, which I'm making a really bad job of here. Once you fit it around the end of the pen, for example, then the idea is that you can kind of leave that measurement in place. You don't have to have it around the pen the whole time. Now once you've got it around the edge of the pen, or you could put it in between a gap, that's what the bits at the top are for, you can now have a look at the scale. So let me talk you through the scale. Now the bottom part is the bit we're looking at, because that's in centimeters and millimeters. The top part is in inches. We won't worry about that for the time being. Now the top bit of the scale, you can see the first line on the etchings on the bottom is just above, between the 5 and 6 millimeters mark. The 1 and 2 mean centimeters, the gaps between millimeters. So that means our first reading is a 5. Now second of all, we are then going to look which notch matches up, or the indents on the scale below. Now that one happens to be, if you count them, the 8th notch. So the 8th notch means the measurement is 5.8 millimeters, and that means it's got a resolution of 0.1 millimeters, the amount it can go up or down by. So let's have a go at some practice then. So for each one, I'm going to give you a couple of seconds, see if you can pause it, figure out what the answer is. So let's have a look at this one here. Now hopefully you can see where this scale starts on the bottom. It's somewhere between kind of 1.1, 1.2 centimeters, or 11 and 12 centimeters. And let's have a look at which notch matches up. So if you count along, none of the notches match up until you reach this one, right one in from the end. So that's the 9th notch. So that reading would be 11.9 millimeters. Okay, example number 2, we can see where the scale starts. Even though you can't see where the 1 is, you can see where the kind of the halfway point between 1 and 2 centimeters would be. So that's 15 millimeters, 16, 17 millimeters. So somewhere between kind of 17, 18 millimeters. Next, let's have a look at the line to see which one matches up. Now, it is a bit tricky. I reckon 4, 5, or 6 kind of match up to a degree. I'm going to go for the one in the middle. I'm going to say the 5th one matches up. So therefore, the reading would be 17.5 millimeters. Okay, so that's Vernier scales looked at. Let's have a look at micrometers then. So pronounced micrometers, even though it looks like it's micrometers, and it actually doesn't have anything to do with micrometers, a millionth of a meter. I'll show you what it's all about here. So let's have a look then. We're going to use the same pen as before. We're going to try and fix the micrometer so the gap is the same as the end of the pen. And let's have a look at the reading. So the way this machine works is you've got the main scale, which goes up in millimeters, and then on the top bit of it you've got halves. So currently you can see I've got 5 and I've got 6 millimeters on this reading. But the question is, what comes after the 6? Now, that's where this spindle at the end comes in handy. Okay, so that was something which I was adjusting the gap with, and hopefully you can read there. It's on 5 currently, but it was actually 6.05, because that could go up to 10, 20, 30, 40. So that means the resolution of the micrometer is 0.01 millimeters, which is better than a Vernier caliper, much better than a ruler. Now, you might be asking, why are the halves there on the top of this scale? Now, the halves are there because this spindle scale only goes up to 50. And once you go to 50, you can see the half of the main scale is visible. So that will be, for example, 6.5. And then you would kind of add the 0.05 onto that. So that would be 5.55. Now, if you add anything on the scale to the half as well, you just have to be careful. Can you see the half on the scale? Yes or no? If you can, then you have to add an extra half onto your millimeters reading. So again, let's have some practice. So try and pause each one, give yourself a few seconds to see if you can figure out what it is. Okay, so let's have a look at this first one here then. Now, if you look on the bottom scale, you can see the fourth notch after the 0, so that means our reading must start with 4 millimeters, and the amount I've gone round on the spindle is 40, roughly speaking. Actually, it's closer to 39. Now, I can't see the half after the 4 millimeters, so therefore this one is going to be 4.39 millimeters. Let's have a look at the next one. So let's spin it around a bit, see what we can get. Okay, so this one, you've got the 7 millimeter point is visible, and then you can actually see the half as well. So that means it's 7.5 plus, and then on the spindle you've got 35. So that one's actually 7.85 millimeters. Okay, now the last thing to note with micrometers is to look at our measurements from earlier. Now, when I measured with a Vernier scale, I got 5.8 millimeters, and the micrometer I got 6.05. Now, other than me doing this quite quickly and not being probably the best physicist and taking my time, there's one other reason for this, which is due to a 0 error. So if you look at the micrometer, when I had it at 0, I can then squeeze it a bit further, and I can actually get it to be a kind of negative number, so it goes around past 0. So that'd be an example of a 0 error, which is going to affect our results. Now, to correct for that 0 error, we are going to need to calibrate it. So it's a really common thing with micrometers. Sometimes when they should read 0, they don't. So how we would go about correcting that is to adjust the ratchet on the end of the micrometer so that it does read 0 when it should, which is going to make all our readings better. And that's known as calibrating an instrument. So I hope you found that helpful. Thanks for watching.